Hello, welcome back everybody. Today we're going to be talking about evidence collection and forensic science and its kind of role, or how the police are involved in some degree, or its importance in policing and criminal justice. So forensic science emerged in the late 19th century with various kind of scientists or pioneers in the field, such as Alphonse Bertillon and Sir Francis Galton. It's really interdisciplinary in nature. It combines biology, chemistry, physics, math, geology, and computer science. So it's all kind of based on Locard's exchange principle, right? That says that basically anytime that you enter a space, you will leave something behind. Could be as little as a piece of your hair, right? Like something very small, a fingerprint, whatever. And in exchange, that space is going to then also potentially leave something on you, right? So think of if you go over to your friend's house and they have an animal, you might leave a little bit of, you might shed some of your hair there. You might also take some of the pet hair with you, right? So that kind of idea of the way that we interact with spaces and things has informed the development in forensic science. Basically, like, hey, there are things that even if they're tiny, we might be able to find somewhere, right? So it could be like a fiber transfer from like one shirt fiber or blanket fiber or towel fiber to a victim or a place. It could be gunshot residue on somebody's hand, right? Or paint chips from a hit and run. All of those things fall into both obeying or falling in line with Locard's exchange principle, but also they are types of evidence that we would want to collect and analyze. It does have limitations, right? So there are some times that we interact with something or a space and we leave no detectable trace, right? So that could be at play. Also, environmental factors can affect trace preservation. So if, you know, a crime happens in, well, this was actually a big part of the like yogurt shop murders in Austin many years ago, was these girls were murdered, but then it was also a fire or an arson. And so the combination of the fire and then all of the things that they have to use to put out the fire, so like different extinguishers and water, all affect like any type of potential traces of evidence that we might have seen had that fire not occurred. So over time, there have been many developments in forensic science. So we've come to find out that things like bite mark analysis, just like microscopic hair analysis, eyewitness testimony, all of those things are incredibly unreliable, and they've led to many wrongful convictions. So since 1989, in the kind of emergence of like new age DNA analysis and technologies, we have had over 375 people whose wrongful convictions were overturned because they had collected DNA evidence in those cases, but at the time that those cases occurred, that technology to analyze the DNA did not exist. And once they did, it was like, you know, proof that the person that had been convicted and put away for whatever crime it was in fact not a match with the suspect's DNA. So therefore, it could not be them that did it, right? We also see like fingerprint analysis is incredibly popular, right? Like, so those are really the two big, very often, like far more accurate or reliable in their producing of identification or like confirming identification. So fingerprint analysis has an error rate of like 0.1%. So like 99.9% of the time it's right. And every now and then it can be wrong. Like you can have a fingerprint, you might have a pattern on your fingerprint that is so close to someone else's that they might mistakenly match you, which happened with the like Madrid train bombing. They had fingerprints, pulled them, matched it to a person here in the United States in like Nevada or Utah or something. Find out he had never even been to Spain, and it was someone else who they just happened to have similar enough fingerprint patterns that they like mistakenly identified this person as the suspect, which that all got sorted out. But it's not fail-proof, right, is really what all that is to say. There are some things that are far more reliable than others. So there's different types of evidence. So if you are planning on being police or in like the legal field or anything like that, like knowing the different types of evidence is very important, right? So you have physical evidence, which includes things that are like the kind of tangible materials. So it could be fibers from your shirt or a blanket, again, right, that kind of stuff. It could be an actual weapon, it could be marks from a weapon, it could be tire tracks, footprints. Some biological evidence does fall under physical evidence, right? So our biological evidence is things like blood, saliva, hair, skin cells, and then any other bodily fluids that would contain DNA for individual identification. So that's all things that can be collected and put like potentially in a bag or a test tube or something like that, right? Then we have testimonial evidence. So this is all things that are spoken. So this can be statements from witnesses, victims, or even suspects. And then digital evidence. So that's like electronic data from our computers, smartphones, internet, kind of logs, and all of that. So those are all the different types of evidence that you could be collecting either as an investigator or as a forensic scientist at a lab, or presenting if you are an attorney. So the kind of crime scene investigation process follows these 4 big steps. So if you arrive on scene as the officer, the first thing that you're going to do is secure the scene and kind of make an assessment, right? So you have to set up boundaries around the crime scene and make sure that it is safe both for other officers and for the teams that are going to be coming in to do evidence collection, whether it's like sworn personnel or a laboratory. Okay, so the amount of effort that takes is different depending on the type of crime scene that it is, but ultimately the goal is make sure it's safe and also protecting the kind of state of the evidence, right? You don't want people traipsing in and out of the crime scene, walking all over things, touching things, moving things around, right? Like it needs to be preserved as best as possible until the folks show up to do documentation and taking photographs and things like that, right? So our next step then is we begin documenting. You're taking like these kind of big overall crime scene photos and then kind of like medium view and then close-ups and then each individual piece of evidence that you have found so far. So you're taking photos and you're beginning the documentation process. that's also where we start to see, or where kind of the chain of custody is introduced. So at this point in time, you're going to start a log of every single piece of evidence that you find. It needs to be documented, and it needs to have a chain of custody, or basically a log of everyone who handles that piece of evidence, where it's going, for how long, from the point it is collected until it is presented to potentially a jury. You're also engaging in systematic kind of evidence collection, so doing these very methodical searches for evidence in that area. So you can do kind of like a back and forth in rows kind of sweep. You can do like a grid, so it's back and forth, maybe right to left, and then turning and going back and forth up and down that little section that you just did. So creating a grid pattern, right? You can search in a spiral, either in or out from the center of the scene. All of those are ways in which people or investigators or forensic scientists will be looking for evidence, or crime lab folks will be looking for evidence. After your evidence is collected, it's going to be sent to a lab for any potential analyses that can be run on it. So like if it's biological evidence, then they're going to be running tests to see if the DNA, what the DNA is, what kind it is, like, and if it matches anybody else's DNA in any of the databases that they have access to. If there's fingerprints, they're going to be analyzing fingerprints and seeing if they match any databases. If it's shell casings from a gun, they might run them through the like ATF's kind of database to see, has this weapon been used before? All of that kind of stuff. So that's kind of the process of from the moment you arrive on scene to through analysis of your evidence. So there are obviously some best practices for collecting evidence. The big thing is make sure that you're using sterile techniques, right? So you should have PPE when you're working or collecting evidence, which includes things like gloves, masks, protective clothing, shoe covers. Any of the tools that you're using to pick things up should be sterilized. You should be trying to avoid cross-contamination, right? So you don't want to be picking one thing up with like tongs, let's say, and then picking another thing up with those same tongs and they're not clean, right? You're risking transferring things between items. Different types of evidence require different types of packaging, so just being aware of that, making sure that those kind of protocols are followed. And then if you have things like biological samples, being sure to get those to a refrigerated space as quickly as possible, because the longer that they are exposed to like heat, the quicker they degrade, right? You want to make sure that all of the evidence is labeled with unique identifiers. There should be information about who collected it, when it was collected. There should be photographs, both before, during, and after the collection process, right? If there is available to you, if you know your GPS coordinates and physical address, as well as like different scene diagrams, all of that should be included with the evidence. And then kind of reporting on the condition of the evidence as you are collecting it. So if something was damaged when you collected it, make sure to document that so that it's not a question of did this get damaged during transit or at the evidence locker, right? Like if it was already damaged, the folks need to be aware of that. So there are some legal requirements around chain of custody, right? So what it is basically just this chronological document of evidence handling from the moment it is collected to when it is presented in court, right? It is done to ensure that whatever evidence you're presenting is legally admissible, And it also maintains the integrity of the evidence throughout the investigative process, right? Like, it's a problem if a piece of evidence was out of the evidence locker or at the lab or something, and that's not documented. So we have no clear, like, nobody can truly or for sure account for where that evidence was and who was handling it, right? So then that introduces some degree potentially of like uncertainty to a jury. If you present to me evidence and there's like a period of even hours, days, weeks, whatever it is, where I'm looking at the evidence log and someone noted that, hey, we don't know where it is. Oh, just it's back, right? Somebody points out that it wasn't around and then it was back, but nobody knows who had it for sure or where it was because it's not documented. Then, like, I as the juror would be like, well, I don't think that I trust that, or I don't know what was done, or it might not even make it past the judge to be presented to the jury if that's the case, right? They might say, yeah, no, you can't use this piece of evidence because this is a major flaw, right? So ultimately, it is on the prosecution to establish that the chain of custody was never broken during the period from collection to presentation. So that's really the big things for both police and forensic scientists, right? So you're showing up, you're securing the scene, you're taking potentially photographs, starting the process of documentation, and ensuring that that process is maintained for the rest of the lifespan of that piece of evidence. So some of the current kind of legal and ethical issues around evidence collection in forensic science are things like scientific validity and error rates, right? So like I had mentioned before, we've had several hundreds of cases that people were later exonerated using DNA evidence, but they had originally been convicted based on maybe just like circumstantial evidence, but in some cases it was things like a quote-unquote expert testimony saying, yeah, that's definitely their bite mark, or yeah, that's definitely their hair that I looked at under a microscope, right? Like, those things all led to wrongful convictions, but at the time they were accepted by judges as being admissible and as being like valid science and trustworthy science. And if you have someone on the stand testifying that they are an expert in this thing and it is certainly able to identify people, but nobody else who has any power to determine whether or not what they are talking about is bullshit or not, right? Like, your attorney isn't going to be scientifically literate. They aren't a scientist. They are not a forensic scientist. Your judge is not going to be scientifically literate. They are not a forensic scientist. They are not really a scientist. Most of the time, probably, right? Your jury, most of the time, probably will be largely scientifically illiterate when it comes to this type of science, like the hard science and that kind of stuff. So if you have all these people taking the word of one person, that can be potentially problematic, right? So that's been an issue, and certainly something that has been on the forefront of reform and kind of like trying to get people in the legal arena to understand, like, not all evidence is equal, and not all evidence should be treated as equal or given the same amount of weight, right? We also have some things like privacy concerns. So if you do like genetic genealogy using something like 23andMe or Ancestry, so you send in a sample, some of those places have these third-party databases that they allow the police to search in, and that becomes a concern of like, well, I didn't consent to a police search, right? Does that violate my right against an unlawful search, potentially, that kind of stuff. So that could be an issue, a potential in terms of like privacy concerns, right? But really kind of the biggest issues and the big takeaways for the kind of criminal justice arena and the process is the kind of those legal ethical standards in terms of like making sure that what is being presented is validated, is reliable, making sure that the experts that are testifying have the qualifications and like those have been vetted for them to be able to get on the stand and discuss this type of evidence and this type of identification method. Making sure that, yes, while we use these things potentially for getting case closure, people's privacy rights are not being violated. As we kind of progress and see the inclusion of things like AI and facial recognition software, that's another issue, right? Of at what point does it become like we are living in the kind of Big Brother state where you're being watched all of the time and you have no right to privacy, right? So those are all potential issues to be addressed. There are obviously some limitations too, like DNA analysis. DNA degrades over time, especially if it's not stored properly. And every time that you use it or analyze it, it takes away, like you can't continue to keep analyzing the same sample. If we have this kind of emergence of things like encrypted messaging apps and things like that, that makes it more difficult to gain access to or recover any type of digital evidence, right? And we also see this kind of like the way that technology is just changing and rapidly evolving. It makes it very difficult at times for science or scientists to validate different types of protocols, right? Like it takes time to establish a body of evidence that would say, yes, this works. It works 99.9% of the time. It should be allowed in the courtroom, right? Like that takes time, and things are changing so rapidly that it can be difficult to establish that body of evidence before places decide that, yeah, we want to try this out, we want to use this. So that is our forensic science, kind of all of the ways that it is a part of the criminal justice system. It's important to note that labs don't work for police departments. They do not work for the DA. They are a separate, like, neutral entity. Their job is not to make a case for the DA. Their job is not to provide, like, a quote-unquote correct answer to police, like, what the police want to know, or, like, try to prove their case. It is to say, this is or is not a match. This is or is not likely to be this person, right? Like, it is a neutral, just providing the facts around whatever evidence they are analyzing. All right.